Hello there, I'm Richard Cochrane. I'm Associate Professor of Renewable Energy with the University of Exeter, based on our Cornwall campus, where our group is working on the latest innovations in offshore renewable energy systems. We've got a group working on the next generation of solar technologies. Then we've got energy storage innovations that we're developing, as well as the power electronics that connect the renewable systems to the grid and the energy policy context. But today I'm going to talk about the wonders of wind turbines, because I think they're fascinating pieces of engineering. They've got some wonderful bits, complicated aerodynamics, the latest composite materials, fascinating control systems, and the structural design of the whole systems is all fascinating. So, what are the wonders of wind turbines? Well, first off, I think it's incredible that we can harness the energy from really gently moving air and generate electricity efficiently from that. But we can do that with systems that can also cope with the phenomenal forces that you can get from the wind if you get stormy conditions coming through. Now, the innovations, developments of the wind, making real improvements across the UK. We have a total installed capacity now of 24 gigawatts. And you can see the numbers of turbines installed onshore and offshore. But what do those numbers mean? Well, every year, that collection of turbines generates as much electricity as is used by 18.4 million homes across the UK. So they're making a real contribution to our electricity demand. And we can see this with the progress that we've been making in decarbonising our electricity. Now, 20, 30 years ago, for every unit of electricity, every kilowatt hour that we used, we were releasing into the atmosphere over 800 grams of carbon dioxide, the greenhouse gas going up. 5 or 6 years ago, that was about 500 grams. And since then, we've pretty much halved those carbon emissions. And that comes in a big part from the contribution that renewables, and particularly wind, are making to our electricity grid. It is a complex picture, but there are nice little apps on your phone, for instance, like this one, that shows what the mix is at any one time. And on this particular day, wind was top of the list, the biggest contribution to our electricity grid. And as a consequence, we'd cut the carbon emissions from electricity generation down to just 86 grams per kilowatt hour. It's a real progress. Now, the technology is really moving on at incredible pace. This is an image of the largest wind turbine that's being tested at the moment. And it just, every single rotation of this turbine generates as much electricity as is used by a house for 2 days. The blades are 107 meters long. So great bits of engineering. And all sorts of challenges in terms of things like manufacturing. They're made in one great big composite infusion process. So that's quite a phenomenal bit of work anyway. Very complex molds for this complicated shape. And then all sorts of challenges like transporting the blades, big bits of kit. But we're getting very good at all of these different processes. You can see here the logistics of taking a blade and delivering it from the factory to the site. As I said, we're getting really good at planning these, working out exactly what routes the blades could take and how to cope with tight bends and other challenges there. So we have all sorts of innovations that I think are fascinating with the wind turbine design. If you look at the blades, I think of them as a little bit like a sailing boat crossing the wind. At any point along the blade, you get a different apparent wind, and that changes how far away you are along from the hub of the blade to the tip, which means our blade geometry is really complicated twist along its length. And that's all about aerodynamic optimization, which we've now got really well sorted. It makes a very complex shape to manufacture, but again, we've got the processes to do that. And as we saw, transport is now solved. Other innovations are coming through, like the idea of using a recyclable epoxy so the blades can be recycled at the end of their use as well. Now, from the outside, perhaps modern turbines don't look that different from modern ones, but inside there's all sorts of innovations. And one of those relates to things like individual blade pitch control. So as a gust hits a turbine, we're trying to maintain that optimal angle of attack of the wind on the blade. And what we do is we twist, the whole blade is adjusted very rapidly so that it maintains that optimal aerodynamic performance as a gust hits. And we can even do that on different sides of the turbine as the blades rotate around really rapidly. Turbines are now also able to sort of see into the future. So using what's called forward-looking LiDAR, sends a laser beam forward from the turbine into the wind and can pick up tiny reflections of dust in the air. And from the reflected image, it can then tell the turbine, say in 15 seconds, you're going to get hit by a gust of this strength coming in this direction. So the turbine can preempt that change in the wind direction. It can feather the blade, adjust the speed of rotation so that it's ready when that gust hits. And that improves the performance and also modulates the load that the turbine has to withstand in stormy conditions. Now, older turbines used to be made with complex structure, electronics inside, gearboxes and things, but now the latest, even the largest turbines are made with what's called direct drive generators, which has surprised the industry of how we've been able to develop these so rapidly and on such a big scale. So this permanent magnet generator improves the efficiency, but also the reliability, because the gearboxes were a challenge to maintain on the old turbines. They also make the turbines quieter, because the gearboxes generated a bit of noise. So we're getting much better performance from the latest ones. But one of the challenges as the turbines get bigger and bigger and bigger is the weight of these generators is getting to the point where we're at the limit of what a crane can lift up to the top of the turbine tower. So other innovations that are being researched are things like superconducting generators. These will slightly improve the generator efficiency, but actually what they could do is enable us to shrink the generator and it can still produce the same amount of power and torque, making it much easier to then install on the turbines. So the last area I wanted to touch on today was floating offshore wind turbines. So far, all the turbines that we've installed in the UK in the offshore environment have been done in relatively shallow water, where we no more deeper than 60 meters. And you can see that areas like Dogger Bank out 130 kilometers out into the North Sea, but we're still only at about average of 30 meters depth across that site. But where, for instance, we're based down in the southwest, you only have to go a few kilometers off the shore and you're already in deeper water than 60 meters. So we haven't been able to develop offshore wind in those areas. But floating wind can open up a greater market, new locations, new sites for these turbines to be deployed. But it's a really challenging area. The engineering of all the wind loading on the top combined with the tide and the wave loading on the bottom and how the structure moves in different conditions is phenomenally complicated. We're working on some innovations in dampers and other systems that can reduce that motion and reduce the loading on the mooring lines. But as well as opening up other sites, floating wind has other advantages. The turbines can be assembled in a port. So you can do that in a range of weather conditions and have bigger bits of kit there to do that. And then the turbines are towed out to the site and linked up to the mooring lines, which has benefits in terms of reducing, for instance, the impact on site. We're not pile driving lots of structures into the seabed. So we can reduce the environmental impact of the assembly of these turbines as well. So great opportunities to extend what we've been doing with wind, increase the number of sites in the UK and overseas. So really exciting times for the wind industry. It's growing at an amazing rate and delivering these real benefits to decarbonising our electricity supply. So fascinating bits of engineering and delivering real benefits, protecting the environment. So thank you very much. Hope you enjoyed that talk.